Hey everyone, welcome to InsightsByRish. In today's video, we are going to talk about feature scaling, which is one of the most important aspects of any machine learning and deep learning model. Now, the agenda of this video goes like, first we'll try to understand the need of feature scaling, then the various and the most popular types of feature scaling. Then we will talk about normalization and standardization. Also, we'll try to implement that. And then we will also try to understand that when to use which method. So starting with the first agenda that we have, which is the need of feature scaling. Now basically, why do we require feature scaling? So this is an example of a dataset consisting of various data for global renewable energy, and here I have basically used the describe method on the dataset. Now this is the statistics that we get from the dataset. Now as you can see, the minimum value and the maximum value for every column is different, which means the column is on a different scale. Like if you check for the column here, the minimum value is 2000 and the maximum value is 2023. Similarly, for solar energy column, the minimum value is 104 and the maximum value is 996. Whereas compared to the year column, when you take the look at the column of other renewable energy, the minimum value is just 54, while the minimum value for year column is 2000, which means for some column the minimum value is drastically high and for other columns the minimum value is drastically low. Same for maximum value as well. For some columns it's drastically high and for some columns it's drastically low. So here what's happening is, while building the model, when you use such kind of data, then in that case every column has a different effect on the model. And we don't want that. We want that every column should contribute equally while building the model. We want the equal contribution of every column that we have in our dataset. But in this case, when the feature hasn't been scaled, in that case what happens is, like, every column has different effect on our model, which hampers the accuracy of our model. So it's very necessary to scale all these columns, and by that what we mean is, we want to scale these features such that we want to make all the minimum values for all the columns equal to each other. And similarly for maximum column as well, we want the maximum value for every column equal to each other. As you can see here, the minimum value is different for every column. For some it's drastically high and for some it's drastically low, and same goes for maximum. We basically want that the minimum value, that is the range between which the values from every column falls, should be same for all the columns. Like if the values from the year column falls between the range 0 to 1000, then for other columns as well the value should fall between the range 0 to 1000 and not from range 0 to 5000 or 10,000 something, because that will again hamper our model's accuracy. So for that we require feature scaling. Now when we move ahead, here we can see the types of feature scaling. Now there are multiple and many types of feature scaling, but the most two popular ones that are used, like everyone uses them, are normalization and standardization. Now this normalization is also called as min-max scaling, while the standardization is also called as a standard scaling or z-score scaling, and we'll talk about both of them. So first we'll start with normalization. Now normalization, which is also called as min-max scaling, what it tries to do, it basically tries to compress the values between the range 0 to 1. Like for every column it compresses the values between the range 0 to 1, which means the minimum value for all the columns will be 0 and the maximum value for all the columns will be 1. And what it does, it basically takes every value, it puts that value into this particular formula that I have displayed here, and then it transforms that value somewhere between the range 0 to 1. And we will also see that how it mathematically happens. And when we try to implement this in any machine learning model, in that case we make use of an inbuilt module of min-max scaler from scikit-learn. We will try to see how this formula works. Give me a minute to explain this formula to you. So as you can see here, this is in first instance, the first row that you are seeing here, this is in first instance. So for this first instance, I am just trying to compress the value from solar energy column between the range 0 to 1. You can apply this formula for each and every value from all the columns here, but I'm just trying to show you an example considering the first instance from the dataset, and particularly the solar energy value. So as you can see, in the first instance, the original value that we have for solar energy is something about 437. So this xi that you have here, this actually shows your original value that you have. Then the minimum value is the minimum value of that column. By that what I mean is, let me go back here, and here you can see the minimum value for solar energy column is 104.555. So this is the minimum value of that column, and the same value we put that here in this formula. This minimum value is 104.555. Then the maximum value is the maximum value of that column. So when you go back here again, here you can see the maximum value of solar energy is 996.97. So this is the maximum value of your column. So minimum is the minimum value of that column and maximum is the maximum value of that column, and x is your original value. Then you have another two parameters which are maximum range and minimum range. Now as you know, we are trying to convert or compress these values between the range 0 to 1, and hence the maximum range we have here in this case is 1 and the minimum range here we have, that is a 0. Now this is the default range, that is by default the min-max scaler converts your values between the range 0 to 1. But if you want, you can even change this range. You can give some different maximum and minimum value here. But for here, the default value is 0 to 1. So hence the maximum range will be 1 and the minimum range will be 0. Now you put all this value into your formula to find the scaled value of solar energy for the first instance. So as you can see, I have put all the values in the formula and then I have computed the value of scale x, which is around 0.37, and the same value you can see you are getting it here when you perform min-max scaling. So this is the first instance from the data set for after performing min-max scaling, and that was the first instance from the data set before performing min-max scaling. The original value was 437 and then we compressed it to the range between 0 to 1, which is now 0.37. So this is how you convert or compress your values using this particular formula between the range 0 to 1. That's a default range. As I said previously, you can change that range, but by default it's always considered between the range 0 to 1. So this was about normalization, which is also called as min-max scaling. Now we will also see how we can implement that. So let's go to the coding part. Now let me write the title here, which is normalization, which is also called as min-max scaling. Now, as I said previously, I am going to use this particular dataset of global renewable energy production from Kaggle. I will provide the link of this dataset in the description box. Now, this dataset particularly consists of some year, the country, and then the values for solar energy, wind energy, and all those stuff. So let me load that data here in the Jupyter notebook. So first I will import pandas as PD, and then I will load that. So df is equal to pd.readcsv, and I already have that dataset here in my Jupyter notebook path, and hence I will just give the name of the dataset here, which is global renewable energy production. Let's run that, and let me display the dataset for you. Now here the country is in categorical column and we are just trying to see how min-max scaling works, hence I will delete this column from this dataset. So let me drop that, and then we will say in place is equal to true in order to make those changes permanent. Let's run that, and now we won't have that column anymore. Let me display that again. Now, as you can see, this is the first instance that I already showed you in my presentation, where the value of solar energy is 437. Now we are going to again perform min-max scaling on this particular data set using the normalization technique. And let me also make use of describe method here. So this is all the stuff that I've already shown you, where the minimum value for solar energy column is 104 and the maximum value for solar energy column is 996. And I already showed you the mathematical computation. Now we will see how it is implemented in machine learning using the scikit-learn library. So for that, first we will say from sklearn dot preprocessing, we will import the min-max scaler library. So this is importing the min-max scaler module from scikit-learn preprocessing part. After that, we have to create an object of this min-max scaler. So let me write here, creating an object of min-max scaler module, and you can name that object anything. Let me name it as scaler, and here again we have to just name the min-max scaler module that we have loaded recently. So this was creating an object of module that we loaded recently. After that, we have to make use of fit_transform method, which is, now this two methods of fit and transforming can either be combined, and you can directly make use of a single method of fit_transform. And if you want, you can also go ahead by first fitting the model and then transforming the values. So here we are just going to make use of fit_transform method. Here what we will do, we will say df, then we will make use of that object that we created recently, which is scaler dot fit underscore transform. This single method will do both the work of fitting the data and also transforming the values. So fit underscore transform, and we will pass our data frame here. Let's run that, and let me display the data frame again after transforming the values. Now here you can see, as I also showed you in the PPT, that now the solar energy value after compressing it between the range 0 to 1 is now 0.37. So this is how min-max scaling is performed in machine learning. So now again let me make use of describe method now. Now you can see the minimum value for all the columns is 0 and the maximum value for all the columns is 1, which means all the columns are on single common scale, and now every feature is contributing equally. I have also shown that here in the presentation. As you can see, after feature scaling, the minimum value of all the columns is 0 and the maximum value of all the columns is 1. And this was the purpose for what we did all those stuff. We basically want the minimum value of all the columns and the maximum values of all the columns equal to each other, which means we can say that every column is now contributing equally while building the model and during the training process. Now, as I said previously, the default value is 0 to 1, but you can even change this range. So how you can do that? Let's see that. So now let me again load the dataset here, and also let me give the title here, which is normalization with different feature range. So I will again load the dataset here. Let me copy the same code, and let me also delete the categorical column. Now let me display the dataset here. So this was the dataset, and here we compress the values between the range 0 to 1 previously. Now we'll try changing the range. So again we will import the min-max scaler module from sklearn. So sklearn.preprocessing will import min-max scaler, and then we will create an object of min-max scaler. In this min-max scaler, we can give an attribute of feature range. So let me say feature range. Here we can give the range between which we want to compress the values. So by default it was 0 to 1. You can even make it 0 to 2. So let me say, or minus 1 to 1. So let me say minus 1 to 1. And then we will again make use of fit underscore transform method here. So scalar dot fit underscore transform, and here I will pass my dataset. Let's run that, and let me again display the dataset here after transforming. Now as you can see, now the values are even in the negative because the range is minus 1 to 1. You can give any range like 0 to 2, 0 to 3, minus 3 to positive 2, anything. You can give any range here. And then let me also make use of describe method here. Now you can see the minimum value is -1 everywhere, and the maximum value is also +1 for every column. So this is how you perform min-max scaling, either by the default range or by changing the values of range. Now we will move to standardization technique. So let me go back to presentation. So we saw everything about min-max scaling. Now moving ahead, we will see how the standardization technique is different from min-max scaling. Now standardization is also called as standard scaling, and this is the second most popular feature scaling technique in machine learning. Unlike the min-max scaling technique where we have a fixed minimum range and the fixed maximum range, here we don't have such kind of fixed range values. Here the basic motto of this technique is to transform the mean of all the columns to 0 and the standard deviation of all the columns to 1. We will come back to this formula in a minute. Let me just go back here, and so this is the original statistical data for our data set. As you can see here, we have one more column in our statistical data here. One is of mean and the another one is standard deviation here. So the main motto of this technique is we want the same mean, that is the zero-centered mean. So mean of every column will be transformed to the value 0, and the standard deviation of all the columns will be transformed to 1. Here we are having different values for mean and standard deviation of all the columns, but eventually we want all of them to be all mean to be zero-centered and all the standard deviation to be 1. Now let's take a look how we can do that and why it is required. Now this is the formula, and as you can see, we will again take an example of the first instance from the dataset for the value solar energy. Now in this formula, the xi that you have is your original value that you have of solar energy, which is 437.086 something. Then your mu, this is pronounced as a mu, which is called as a mean of that column. I already shown you the mean of that column. Let me show you again. The mean of that column, solar energy column, is 528.525, and the standard deviation of solar energy column is 271.183, and we are going to use these two values there in that formula. So the mean of the solar energy column is 528 and the standard deviation of solar energy column is 271. Now we are just taking the look at solar energy column, and hence we are seeing all the statistical data for that particular column. So here, as I said previously, mu is the mean of that column, which is 528, and this symbol is of sigma, which is the standard deviation of that column. And this all values you put in the formula to get the scaled x. So let me move ahead and show you. This is the computation. This is the mathematical computation. You put all the values in that particular formula, and after putting that, you get a value of negative 0.337. And when you display the data set, you can see the value that we computed by mathematical formula is very equal and very similar to the value that we obtained by using the standard scalar library from scikit-learn. So this is how standard scaling is performed. And after performing that, you can see after feature scaling, that is after performing standardization, the mean of all the columns is 0. Now this is e raised to negative 70. So this is a very small value, like 0.000 something. So this is around 0. This is just tending to 0, which means the mean of all the columns is 0 now. And the standard deviation of all the columns is 1. So this is what the standardization technique does. Now you might ask a question that why we require the mean to be 0 centered and the standard deviation to be 1. Why is it basically required? So for that, now in linear regression, in any kind of regression algorithms, and wherever we use the gradient descent techniques, in all those algorithms, our basic motto is to reach the global minima. We basically want to minimize our error, and for that we want to reach the global minima, which is here displayed using the green arrow. So this is the global minima position where we eventually want to reach, and this is our starting position. So the process where we reach from the original position to our global minima is called as convergence. Now when we make our mean 0 centered and when we scale the standard deviation of all the columns to 1, it makes the convergence in any kind of gradient descent optimization very faster. Now this red point is our local minima. Many times what happens is our point basically stuck here, assuming that this is the global minima, but actually it's not global minima. So in case when you want faster convergence from the original position to your global minima, in that case you make use of the standard scaling, where you make all the mean 0 centered and the standard deviation to 1. And again, another reason, as I said previously, is equal feature contribution. But again, the first reason was the main that why we require standard scaling is in any kind of distance based algorithms or any kind of gradient descent, when we perform deep learning where we have neural networks, in that case we also make use of gradient descent, stochastic gradient descent optimizers. In that case as well, our motto is to reduce the minimize the error and to reach the global minima. And even there we want faster convergence, because as fast as the convergence happens, the error is minimized and the accuracy is increased. So whenever we make the mean 0 centered and all the scale, that is all the standard deviation, equal to each other, in that case we obtain or we achieve this faster convergence. So this was the reason why we want all the mean to be 0 centered. And let us see how now the standard scaling or the standardization technique is performed by coding. So let us go back to the code. So let me give the heading here, which is standardization. And we can also call this as standard scaling or z-score scaling. So again, we will load our data set, whatever we did previously. Let me run that, and let me also drop that country column, which is a categorical column. And then in place is equal to true in order to make those changes permanent. Let's run that, and let me display the data set here. So this is the first instance for which I've shown you the example. Now let me also make use of describe method here. You can see the mean and standard deviation for all the columns is different. Now we will make use of standard scaling here. So let me say from sklearn, now we import the standard scalar module from scikit-learn preprocessing again. So both the modules are imported from sklearn preprocessing module or preprocessing library, sklearn.preprocessing, and from here we will import our standard scaler. So similar to min-max scaler, here as well we will create an object of the standard scaler. Let us again name it as scaler, or you can name it anything, and in which we will load our module, that is standard scaler. Now after this min-max scaling technique and standard scaling technique is very similar to each other. Like just the differences of module, like here you make use of min-max scaler here, and here you make use of standard scaler. Everything else remains same. Again we will say df is equal to the object name, which is scaler, and the fit underscore transform method, and we will pass our dataset, original data frame here. Now let me make one thing clear. This df data frame that we are passing in fit underscore transform method is our data frame that we have loaded here, in which we have loaded our CSV file. This is our existing data frame that we are passing it here in the fit underscore transform method, and this df is the new data frame with the same name. This df is the new data frame with the same name, df. And the reason behind putting the square bracket and the colon is, if you don't put that, then all your transformed values will be stored in the form of array and not in the form of data frame. But when you want to make any kind of visualizations, or when you want to build your machine learning models, in that case you require all the values to be stored in the format of data frame, and hence in order to store those transformed values in the form of data frame and not in the form of array, we just make use of the square brackets and one single colon. Let's run that, and let me display the dataset here. As you can see, now the values have been transformed, and this is what I already shown you in the presentation as well. The solar energy for the first instance, the solar energy value transformed from 437 to negative 0.33. And when you even make use of describe method here you can see the mean is 0 centered. These values are very small. You can see it's basically e raised to negative 17, e raised to negative 16, and all those stuff. So these are very small values, like 0.000 something. So this is nearly or tending to 0, which means the mean have been 0 centered, and the standard deviation for all the columns now have been transformed to 1. And this was the purpose of the standard scaling library. Now we saw the min-max scaling implementation and also the standard scaling implementation. Now the main thing for us to understand is when to use which scaling technique, and for that we'll go back to the presentation again. So moving ahead, the last agenda of this video is when to use what. Now normalization or min-max scaling is used when we have some distance based algorithms, like we have KNN, K nearest neighbor, or SVM, that is support vector machines. When we have any kind of distance based algorithms where we basically are trying to compute the distance between 2 points, in that case we make use of min-max scaling technique. Or whenever we are trying to build neural networks or any kind of deep learning model, in that case we make use of normalization technique or min-max scaling techniques. And when we are trying to make use of any kind of regression algorithms like linear regression or logistic regression, in that case we make use of standardization technique. Then the second difference is when you have many outliers in your data set, like even after handling the outliers you still have some of them, like whenever you make use of IQR, outlier detection and removal technique, like interquartile range, in that case you make use of predefined lower bound and upper bound formula. So there you only remove some outliers, but you still have some outliers prevailing in your data set. In that case you won't be using min-max scaling, because this min-max scaling or the normalization technique is highly sensitive to outliers. It will affect or it will change drastically if there is any effect of outliers. So when you have any kind of outliers or large number of outliers in your data set, you won't prefer min-max scaling. But if you can go ahead with standard scaling, because the standard scaling or the standardization technique is not very highly sensitive to any kind of outliers. Like when you use the z-score or standard deviation or percentile method for outlier removal, in that case you give the lower bound and upper bound values manually, and in that case you remove almost every outlier. But when you make use of IQR, outlier removal technique, in that case you tend to remove some outliers, but you still have some outliers prevailing in your data. In that case you can go ahead with using standard scaling instead of min-max scaling. And the third and the last difference here is the regularization models. Now, when you make use of any kind of regularization models like ridge regression, lasso regression, in that case, you won't be using the min-max scaling because it won't yield you a good accuracy. But in that case, you can go ahead by using standard scaling. So whenever you're performing any kind of regression, whether it's a linear regression or whether it's an regularization regression like a lasso regression or ridge regression, in that case, you by default you use standardization technique or standard scaling technique. And when you are not building any kind of regularization model, in that case, you can go ahead with min-max scaling. So this was the last agenda for this video, that when to use what. There are many more differences, but these are the standard and the important ones. I have also written an article on Medium about the same that includes entire stuff about feature scaling that I explained right now. I will also provide the link of that article in the description box. If you want, you can go and read that as well. So that's it for the video. Thanks for watching.